Okay, so good morning, everyone. I'm Ekbordin Winijkul. I'm the assistant professor in the Environmental Engineering and Management program at AIT.
Good morning, everyone. My name is Sompoke Kingkaew. I'm the PhD student at Rental Engineering, in, sorry, Rental Engineering and Management. I'm also the lecturer in Thammasat University. And thank you for having us this morning.
Okay, so let me start with how can we use AI in the environmental field or focusing on atmospheric environment. So, first question, why we need to use AI for air quality management? I think in the past you have a lot of experience that maybe in the US or maybe in European countries, they have been managed their air quite well, right? In the past, even though maybe like more than 50 years ago that we may not talking much about AI during that time, especially for me, but not for you guys. Maybe you guys already talk about AI that long before. But for us, maybe during that time, we didn't have think about, okay, how can we apply AI into air quality management? But the things that I put on the slide is the first, maybe in the past, we know what we can see, right? For example, if you are in Bangkok or maybe in some country that we have still have the problem of air pollution, in the morning when you wake up, you're gonna see like the sky with maybe foggy sky. And then if you want to go for a run or jogging in the morning, you're gonna see that, oh, whether I should go out today because if I go running, then I'm gonna breathe more bad air into our lung, and then that may not be good for your health. Anyway, those also not only things that happen in the atmosphere. We found that there are actually two types of air pollution. The first one is primary pollutant, which directly emit from the source that you can see, or maybe you cannot see. But the second one is the secondary pollutant that usually develop in the atmosphere. And in the past, we may not be able to account for those kind of secondary pollutants because there are some chemistry that happen in the atmosphere that may be too complicated for us in order to put into the model. But right now, because of the AI, because of data involvement, that we can put those kind of information and then make the estimation better. Yeah, we still, can you go back for one slide, sorry? And also the amount of data that we take is really like compared to the past is totally different. In the past, we're talking about maybe we don't have enough data, right? But right now, wow, the data is coming every second. So too many data for us to process, and then we could not maybe be able to process by ourselves. We need something to help us in order to do that. And then last one, I think everyone gets spoiled by the information that everything needs to be real time, everything needs to be local specific, right? Because if you want to go, the same example, you want to go out doing some jogging, you don't know what is the situation of the air quality in the past hour. You want to know it's right now, right? And then also you want to know at your location is not just maybe 1 kilometer away from what you are located, right? So this kind of the information that why we need to put AI into the air quality management right now. And then in terms of air quality management, you can see on this slide that we have three things. Those are the common tools that we use for manage air quality since long time before. The first one is air quality monitoring. The air quality monitoring is tell us what is the current situation of the concentration of different pollutant currently, so that if it's bad, then we need to do something to get it better. Or if it's good, then can we do it better, and so on. The second one is about the emission inventory. This emission inventory, we are talking about if we want to manage the air quality, where are the source of the pollution in the countries. And then on the last one, air quality modeling. So this one is also the important tools, because imagine that if you want to try to apply some policy in your study, if you're doing in the real situation, maybe, okay, we apply the current we apply the new policy in, we need to wait maybe 1 or 2 years in order for that policy to be effective. And then we need to monitor those kind of change in the real situation. But with the application of air quality modeling, we can shorten the time. We apply the policy into the model. We shorten the time to be maybe in the 1 day or maybe less than 1 day, and then we can get the result of that. Yeah. Next slide, please. Okay, now we're going to talk about some example of AI that we use in air quality management. Yeah, please, next slide. I will go to focus on 3 tools that we use for air quality management. The first one that we are going to talk about going to be relating to the air quality monitoring. I think maybe another example that I can point out here is, I'm not sure whether you realize that the small device that you put in your household to measure the air quality, those one that we call sensor that tell you what is the quality of the air in your household. In some company, they also collect the information from that device and also send to the central processor in order to analyze the concentration. So meaning that all the information from different households sending like maybe second by second, and then there's going to be some computer or machine that process those kind of things and then produce the data that we want. So in this case, another application, we would like to, so actually if you thinking about the air quality monitoring, the monitoring station that owned by the government that are the certified one are very expensive, like in the scale of more than million, like maybe 10 million or something like that. So we could not put into all of the location. The map that you see is the map of Chiang Mai city. Then usually very small district, only one district, the city center that's going to have monitoring station. But with the application of the satellite, we can make the relationship between what the satellite measure compared to what we measure at the ground, and then make that relationship and then apply those applications into different locations in the map. And then we can have those kind of information in different time, different location. Next one, I'm going to talk about emission inventory. So to do emission inventory, we need to know where the pollution coming from. And then on the left-hand side, you're going to see a traditional way of we do traffic survey, right? In the past, if you're old enough like me, you're going to see like a group of people sitting along the street and then count number of vehicles that pass through that intersection. And if you have good number of students, then you can cover all location in the city. But this is going to take really long time. Imagine that you want to do for whole city, maybe take a month at least, or maybe a year in order to do that. But right now on the right-hand side with application of maybe Google or maybe TomTom or something like that, that they can provide information. And also with the AI technology that maybe someone showed to you before that we have the traffic camera, those can identify what type of vehicle, how many volume that they have. So we can bring in all that information together and then provide to the information in the next slide. So right now you can see that the information is the carbon monoxide emission that's changing with time. So every time you click, this will link and then give you the information of how much emission that come from different road on the street, like instantaneously. Okay, and then last example going to be the air pollution, air quality modeling. So if this one, usually in the past, we try to link the data together and then we try to estimate the concentration of pollutant in different locations. On the right-hand side, you can see the predicting model that we try to predict between PM 2.5 and observed compared to the observed data from the monitoring. Anyway, if you see this, the point that we put in is not much, maybe 50 or something like that. But in the help of AI application, we can put more data. And then the one that we are familiar with in our field is the ANN, Artificial Neural Network. Anyway, we can use that to give our prediction. Anyway, I put one note on the back, on the bottom of the slide that, okay, the relationship among the input parameter need to be explained because the AI is so good. Even though you put something that we think that it should not have any relationship, but it will file for you, right? Okay, so on the last slide, I would like to put some note here that AI provide new way for data processing, simulation, presentation for the atmospheric data, and that will be good for air quality management. The near real-time information are useful for different business, for example, the elderly home, market analysis. And then one big note here is use AI with caution, because users need to understand the mechanism behind to be able to explain the behavior of the environmental system. With that, I would like to hand the stage to Mr. Sompoke, who will be talking more on the application.
Thank you, Dr. Ekbordin. Okay, this is my session, and Dr. Ekbordin already mentioned about the applications in air quality monitoring, modeling. For me, I will focus on the air quality modeling that I have been work here at AIT as my PhD dissertation. Okay. So we try to incorporate the model and also try to use the data from various sources and use the machine learning and try to apply AI to have a better prediction of air quality in Thailand. So next slide, please. Okay. Before I go there, I would like to mention a little bit about the environmental development using the AI, which AI can play a role in supporting or also inhibiting the application in the environment development, especially for the climate action. So we focus on the clean energy and also low emission society. So if we apply AI in this context, so we have to find a solution, or we have to find the source of clean energy that can supply AI or our resources that can work effectively and efficiently. Okay, next slide, please. So why we need AI in inventory research? So for us, we would like to learn how the real world environment is. And for that, it has human activity and natural activities that come with the big data. Actually, this kind of activities, we have to collect all information and data. So some data we can collect, but some data we could not. So why we need the data? The data we use for transform something into information to understand the complex interaction process of the environment, especially for the air quality aspect. We would like to understand the secondary particulate matter or secondary pollutants that form in the atmosphere through the process of chemistry. So these we need the modeling and also the AI that can be help us to understand better and predict air quality in the future correctly. So what we need the near real-time data. We need the near real-time simulation that can simulate the four-dimensional real-world environment. Why we need four-dimensional? So actually, when we talk about the model or something, we mentioned just only the location. But now what we need the specific location is not enough. So we need the time. So if we can predict faster, we can prepare better. So what we need the rapid forecast. So for us, we would like to apply the AI and big data to simulate the air quality, and also would like to make it at near real time as much as possible. Okay. So why air quality forecast is important in nowadays? So we have the monitoring station that Dr. Ekbordin already mentioned. We have the limitation of standard monitoring, and also we have the emerging of the sensor. But this kind of data still have something to work on a lot, especially for the accuracy of the data. So how can we assimilate this kind of data together to make it better for the prediction of air qualities? So in terms of the machine learning and forecasting, we need this kind of data, not only for prediction, but to have a better model that can train by the good data. We need the good data to construct the model and to test our model that can be work better. So nowadays we have the PM2.5 issue in Bangkok or in Thailand. Uh, some source have been blamed as the contributor to the PM2.5, right? So some they try to argue that I'm not. So, but who we know who is the major source? So we try to quantify the emission and quantify the contribution. So when we need to quantify, so we would like to help them to control the emission better, to come up with the management of their work, their activity that can reduce the emission from the activities. So many industries have been contacting us to help them to identify the emission from this source and work together to plan how we can control the emission during that period. So they would like also to have a better environmental responsibility that can work and can have the business with the good environment and the good community, society, with a healthy community. So they also care about the human health. So here we work together how to come up with the better environmental responsibility for the business. So in my research, and also we try to translate our research into government sector and also private sector using the AI and machine learning and also our modeling to come up with the air quality forecasting. So these figures try to depict how we can simulate air quality at near real time. So at near real time, what we need the observation data at near real time. Observation data, satellite data, and also other data from various sources. So we have to translate this data into information about the emission. So from the source, sometimes we could not find the useful data. But how can we try to make something better or improve the prediction? So for example, we need the traffic data. Dr. Ekbordin already mentioned about the pattern recognition for the vehicle type. What we need to do, we need to estimate how much the PM2.5 emit from each vehicle. So how do we know each vehicle in each road, how much it is and what kind of vehicle? So we need something to identify it. So we can use the CCTV camera, use algorithm to identify. So if we come up with that data, we can translate into emission. So from the emission, we can put it in the model. So before we run the model, we have to compare with other data as well, especially for the open burning, the forest fire. So this data we try to estimate from the satellite data, but everyone knows that the satellite data it has the limitation of the observation. The satellite parts some area in some time is not covered much in some areas. So how we can work it better? We can use drone in the future, maybe. The drone networking making something better, but for the data, we still have the limitation of confidential. So if it would be better if we can share the data from the government, from everyone, or in the future, that business sector, they can put the sensor or put some kind of the data collector from each device that we can share together as the big data, the whole world, and then we can put in our model and simulate it faster and better. So from the equity forecasting, we try to not only forecast and show it, we try to connect with the people and client, translate into the mobile applications that, okay. So can you go next slide, please? So for us at engineering and management, we try to work with the government and we try to work with the private sector. What we offer and what we are doing right now, we are working on the side of environmental data management. We consult the industry partner that can have and come up with the better data management for air quality or environment. We have the application of air quality modeling from conservative one that can be advanced in the future. So it's short-term and short-term and long-term implementation. So we also work on the climate data scaling and climate simulations. And in the future, if we focus more on the emission scenario, we can develop together. And the emission inventory, we have been work on this a lot and join with the governmental sector and try to translate this information into the policy. So yeah, we hope that we would like to have a scientific-based policy that can have better policy for us. So others, we work with GIS, motion sensing, and data visualization. So we would like to focus also for the data format in the future, for scientific formats, for example, NetCDF, whatever. Okay. So the coming project for us, we have been work with the private sectors. For example, in the Suvarnabhumi, Mantaput, we try to help them to work with the environmental quality data and try to deal with the governmental sector to solve the issue based each year, for example, PM2.5 in Bangkok or in Nepal. So we try to apply this AI and other information and with the quality modeling to have better management and control. So here's our business partner and research. We work with governmental sector and also with the AI center, and many projects we have to deal together because I need your consultant. And we work with the private sector that deal with government also. So that's all for my presentations. Thank you.
Thank you guys so much. And I love your presentation for the fact that, you guys really point out how important it is for, if you want AI to work, you have to, one, share data, right? And you have to really work together to solve some issue. So one of the reasons why I really wanted to invite this team in environmental engineering is that they first need the R&D from basically computer science team to apply for them to help get more data that is more real-time and live data, and then process it in another layer that is AI model to get the information out and then apply visualization to it. And then also in the end, they calculate the impact on individual health of society to know, okay, pollution level like this, what happened to the elderly people, right? They're having more breathing problem, they're dying faster because of higher pollution levels.